Hello class, this video we review for exam 4. Let's look at the first question. Find the integral. The integral of the difference. The function is the difference of two functions, right? 9 over x minus 2 over x squared dx can be written as the difference of the two integrals. So integral of 9 over x dx minus or plus 2 times negative 1 over x squared dx. Can we find the antiderivative of 9 over x is 9 ln n, absolute value of x, right? And which function whose derivative is negative 1 over x squared? I ask you to remember this formula. The derivative of 1 over x is negative 1 over x squared. So the antiderivative of negative 1 over x squared is 1 over x. So we have plus 2. The coefficient 2 remain as coefficient times 1 over x, all right? And do not forget to put a c. C here represents any real number. If you are not sure, you can always reverse the process. Take the derivative of the result. If you have the given function, then that means your result is correct, right? If we take the derivative of this result, we have 9 times 1 over x plus 2 times negative 1 over x squared, right? Yeah, constant, take the derivative is 0. So we're going to enter this here. 9 ln absolute value of x. 9 ln absolute value of x plus 2 over x plus c. I use capital letter C to represent the random real number. Double check. Right. Next. Let me check if the video is recording. Okay. Question number 2. Take the derivative of, take the integral of 2 times e to the power of negative 0.1x. Which function whose derivative gives e to the power of kx? Is e to the power of kx over k, all right? Then you can double check. E to the power of kx over k gives the derivative e to the power of kx. So with that said, the antiderivative of the function is going to be 2 times numerator e to the power of negative 0.1x over negative 0.1, okay, and then plus c. You can double check. We keep the coefficient 2 here, and then the derivative of this function is e to the power negative 0.1x times negative 0.1. That will cancel the denominator. So you will have 2 times e to the power of negative 0.1x. We can simplify the result a little bit. 2 over 0.1. If we divide 2 by 0.1, we should have 20. And don't forget the negative sign. So we have negative 20e, negative 0.1x plus c. All right? So let's enter that. Negative 20 e to the power of a negative 1x plus c, cap letter c. Yeah, I always double check the result by taking the derivative of the result. If I have the original function in the integral, then that means my answer is correct. For most of us, we are more familiar with taking the derivative compared with taking the integral. So that's a method, a strategy to help you have a higher successful rate on the problems, right? Okay, next. Question number 3, find the integral. So the hint reminds you to expand the function first. You remember how to FOIL? Let's see. The function is 9x plus 4 to the power of 2. And you can FOIL 9x plus 4 times 9x plus 4. 9x times 9x, 81x squared. 9x times 4, 36x. 4 times 9x, 36x. 4 times 4, 16. So we have 81x squared plus 72x plus 16. All right. So the integrated function of the integral is a sum. The integral of a sum is the sum of integrals. So we can write the integral as the sum of 3 integrals. 81x squared, 72x dx, 16 dx. All right, 81x squared, 72x, 16. The antiderivative of 81x squared is 81x cubed over 3. All right, you remember the formula, right? Raise the power to up 1 from 2 to 3. You add 1 to 2, you get a 3. And then divide that by n plus 1. So the antiderivative of x squared is x cubed over 3. I hope you already know the formula. And then continue. We keep 72. The coefficient remains as coefficient. The antiderivative of x is x squared over 2. Right? So the formula says the antiderivative of x to the power of n is x to the power of n plus 1 over n plus 1. Okay? So that's how do we know the antiderivative of x is x squared over 2, and antiderivative of 16 is 16x, and then plus c. Let's simplify the result. 81 divided by 3, 27 cubed plus 36x squared plus 16x plus c. All right, let's enter 27x cubed x cubed plus 36x squared plus 36x squared 36x squared 16x plus c. All right, use the method I mentioned. Double check the result. Taking the derivative of this function, 81x squared 72x plus 16. So that's correct. Next. Number 4. Accompany finds that the rate at which the quantity of a product that consumers demand changes with respect to price is given by the marginal demand function. So d prime is given. D of x is the demand function. D prime is the rate of change, marginal demand function, negative 3,000 over x squared, where x is the price per unit in dollars. Find the demand function if it is known that 1,004 units of the product are demanded by consumers when the price is $3 per unit. Okay, so this problem let me hide the floating bar. Okay, so to solve this problem, our goal is to find the dx, right? We're given d prime. Okay, I don't need to do this actually. We're given d prime, we're looking for d. So we need to take the integral d of x. We do d prime x dx. So that is negative 3,000 over x squared dx. The antiderivative of 1 over negative 1 over x squared is 1 over x. Okay, again, we use this formula multiple times already. The derivative of 1 over x is negative 1 over x squared. So the antiderivative is 3,000 over x. Okay, if you don't see it, how about we factor out 3,000? The coefficient can be taken outside the integral, and the function is negative 1 over x squared. Its antiderivative is 1 over x. So it's 3,000 over x and plus c. Okay, so we have d of x equals 3,000 over x plus c. If we know the value of c, then we're done. How do we know the value of c? We have extra information from the problem. The problem says when x is 3, x is the price per unit, right? When x equals 3, the demand is 1,004. So it's given that as x equals 3, d of x or d of 3 is 1,004, right? 1,004. So that condition would help us to determine the value of c. So that means when we plugging in x equals 3 here, we plug in x equals 3. So we have 3,000 over 3 plus c equals the demand is 1,004. 3,000 over 3 is 1,000. C is 4. Okay, so the d of x that we are looking for is 3,000 over x plus 4. That's the answer we need to enter here. 3,000 over x plus 4. Sorry, plus 4. Yeah. And we can double check. Firstly, it satisfies the condition when x equals 3. D is 1,004. Secondly, the derivative of the function is negative 3,000 over x squared. So that's definitely correct. Next, question number 5. 2 parts. Part A, approximate the area under graph A of f of x over the interval 2 to 10 by computing the area of each rectangle to 4 decimal places and then adding. B is the same, also from Same function from 2 to 10. Okay. So I need to make this bigger. Okay. We're going to take time to solve this problem. Okay. We're adding the rectangles in a graph, adding the area of the rectangles in a graph. Okay, so how many rectangles? 1, 2, 3, 4, right? 4 rectangles. And the function is f of x equals 3 over x squared. Okay, so the first rectangle, the height, the first rectangle, the height is f of 2. I hope you see it. So this point, x value is 2, y value is f of 2. Okay, and the second rectangle, the base is 2. All the 4 rectangles have a base 2. And the height is this, is the y value of this point, and that is f of 4. Okay? And the third rectangle, the base is 2. The height here is f of 6. And here, the fourth rectangle, the height is f of 8. Okay? So the addition, the sum of the area, let's use S. Yeah. The sum of the areas of the 4 rectangles equals the first rectangle, base times height. Second rectangle, base times height. The third one, base times height. The fourth one, base times height. Obviously, we can take 2 out, right? F of 2, this is f of x. F of 2 would be 3 over 2 squared. 3 over x squared, so it's positive. And f of 4 is 3 over 4 squared. And here f of 6, 3 over 6 squared. F of 8, 3 over 8 squared. And as you can see, in the bracket, all the 4 terms have the coefficient 3, and we actually could factor 3 out. Factor 3 out, 2 times 3 is 6. We have 1 over 2 squared plus 1 over 4 squared plus 1 over 6 squared plus 1 over 8 squared. And more specific, 1 over 2 squared is 1 over 4, and that is 1 over 16. It's 1 over 36, that is 1 over 64. And you just need to do the calculation. I know you don't like fractions, so we're going to use calculator. Okay, I'm going to show you how to do that. We're going to add those fractions together, and then we multiply 6, all right, because of commutative property. We go 1 over 4 is a fraction, plus 1 over 16, plus 1 over 36, plus 1 over 64, right? Let's see, 1 over 4, 1 over 16, 1 over 36, 1 over 64, okay. And then times 6, times 6. How many decimal places we need? Part A. Four decimal places, so we have 1.4236. 1.4236. 1.4236. Okay, that's the first part. All right, I'm gonna copy paste the second graph, make it bigger. What's the difference of this graph compared with the previous one? We have more rectangles, right? The number of rectangles actually, let's see if it's doubled. From 2 to 10. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, doubled. The base, the width of the rectangle, the base is 1. Earlier is 2, now is 1, right? So make the division thinner. So we're gonna add the 8 rectangles together, the area of the rectangles together. Let's look at the first rectangle. Knowing all the rectangles has base 1, that's very obvious, right? This base is 1, this is 1. Yeah, all the rectangles has base 1. And the height of the first rectangle right here is f of 1. The others are f of 2, okay? The second, so the first, the area of the first rectangle is 1 times f of 2. The second rectangle, 1 times f of 3. And we do not have to always write 1 times. So we're gonna get rid of the 1. And then plus this 1 times f of 4, this f of 5, f of 6, f of 7, f of 8, f of 9. So we're gonna add them together. Okay, so we have f of 2, f of x is 3 over x squared. So f of 2 is 3 over 2 squared. F of 3 is 3 over 3 squared. 3 over 4 squared. 3 over 5 squared. 5 squared. 3 over 6 squared. 3 over 7 squared. 3 over 8 squared. 3 over 9 squared. 3 can be taken out, okay? Yeah, we're gonna add those 1 over the rest, actually sum or reciprocal of the first 9 natural numbers square. This is, just remember, it's from 2 squared to 9 squared, all right? From 2 squared to 9 squared. One over 2 squared, 1 over 4. 3 squared, 1 over 9. 4 squared, 1 over 16. 5 squared, 1 over 25. Are we doing all right now? So 4, 9, 16, 25. Continue. 1 over 36. 1 over 47. Oh, sorry, what did I say? 7 squared, 49. 6 squared, 7 squared, 8 squared. 8 squared is 1 over 64 plus 1 over 9 squared is 81. Right? Yeah, unfortunately I don't see the part that is hidden right now. So make sure your entry is correct. That's what we intend to tell the calculator. And then don't forget to multiply by 3 times 3. 1.6193. Okay. It's not very difficult, this problem is just very troublesome. This is related to the definition of integral. Integral is the sum of infinite items. So this tells you the transition from finite to infinite. If we make the number of the rectangles more and more, then the sum of the areas of those rectangles gonna approaches the area under the curve. You should look at the textbook about that. So now let's look at next question. Question number 6. A concert promoter sells tickets and has a marginal profit function given below, where P prime is in dollars per ticket. This means the rate of change of total profit with respect to the number of tickets sold X is P prime. Find the total profit from the sale of the first 120 tickets, disregarding any fixed costs. All right, so we have P prime. We're looking for the profit, cumulated profit. So we're looking for the first 120 tickets, right? So from 0 to 120, P prime X dx. That's what we need to find. Okay? Accumulating total profit means accumulating profit from the first 120 tickets. So from 0 to 120, P prime X dx. From 0 to 120, P prime X, which is 5X, minus 1172 dx. All right, so the antiderivative 5 remain as coefficient 5. For x, we have x squared over 2, right? And this one, 1172x. You should be very familiar with the formula now. And we put the antiderivative in the bracket. This is the way I process definite integral. And put the upper limit here, lower limit here. And I'm going to have a difference of 2 parentheses. In the first parentheses, we will have the value of the function in the bracket as x equals 120. In the second parentheses, we're going to have the value of the function when x equals 0. So we know here's 0, right? Don't have to worry about the second parentheses. We only need to plug in 120. So that gives 5 times 120 squared over 2 minus 1172 times, I need more space, times 120. Okay, and that gives, this basically is 5 times 120 times 60, right? And then minus 1172, 120. The 120 squares 120 times 120. Take one of them to divide by 2, you get a 60. So that's how I get that. So we can use a calculator. 120 times 300. Where do we get the 300? 5 times 60 is 300. So 120 times 300 minus parentheses 1172 120 1172 120 1172. Okay. Negative 104 640. Negative, do not forget the negative. Profit could be negative. That means the beginning you don't start to make money yet because you put a lot of money investment upfront. So normally take a while to get it back, to get it back. Okay. You double check the unit. Total profit in dollars, right? This is in dollars per ticket. Negative 104 640. All right. Next, question number 7. A particle is released as part of an experiment. Its speed t seconds after release is given by, so we have the velocity function, meters per second. Part A, how far does the particle travel during the first 3 seconds? How far does it travel during the second 3 seconds? Okay. Sometimes when the problem does not make sense to you after you read it once, just read it more times. The more times you read it, the more sense you can make of the problem. So what happened to this problem is we are given the velocity function v of t. V of t. V of t equals, go back to see this. Okay, the velocity function is given. Do you remember the relationship between the distance function and velocity function? S prime t is vt, okay? So we're looking for the accumulating distance. So we're looking for the derivative, the integral, the first 3 seconds. Read it again. The particle travels how many meters in the first 3 seconds? It is it's important to check the unit. First 3 seconds, 0 to 3, S prime t dt. And that is 0 to 3. Vt dt, because S prime is v. And we put the velocity function here, which is a negative 0.6 t squared plus 14 dt. The antiderivative, negative 0.6 t cubed over 3 plus 2t squared. If you're not sure, double check, all right? So actually we have, I can change here as negative 0.2, negative 0.2 t cubed. All right, if you're not sure, you can double check. Negative 0.2 times 3t squared is negative 0.6 t squared, and that's 4t. And from 0 to 3. Again, when we plug in 0, we get a 0, right? So we don't really have to worry about that. The result is going to be the value of the function in the bracket as t equals 3. Plug in 3. 3 cubed is 27. 3 squared is 9. Double 9 is 18. -2, 27 plus 18. So we get a -2.2. -0.2 times 27 plus 18. Okay. 12.6. This makes sense. Let's think about, does that make sense, the result? The particle is released, so it's a free fall for 3 seconds, 12 meters, 12.6 meters. That makes sense. It's reasonable. Round to 2 decimal places is needed. Okay, part B. The particle travels how many meters in a second? 3 seconds. So that means we're looking for the second 3 seconds. We should start with 4, 5, 6. We should start with 3. 3 to 6. 0 to 3, that's the first 3 seconds. 3 to 6, that's the third second. That's the second 3 seconds. Okay. And then we do the same thing. Okay. V of t dt. So 3 to 6. Negative 0.6 t squared plus 4t dt. So that gives us -0.2 t cubed plus 2t squared, 36. -0.6 t squared plus 14. Okay, so we're gonna have parentheses minus parentheses. In the first parentheses, we plug in 6. -0.2, 6 cubed plus 2 times 6 squared. In the second parentheses, we plug in 3. 3 cubed, 3 squared. Minus 18. So we're gonna have negative, let's see what is 22 times 20, 6, 216. And that gives negative 43.2 plus 72 plus 5.4 minus 18. Those problems are not very challenging. It's just requires you being careful. Negative 43.2 with a handheld calculator would make it a little bit easier because I'm making videos. Double check. 16.2. Next, question number 8. A company estimates that its sales will grow continuously at a rate given by the function, where S prime is the rate at which sales are increasing in dollars per day. On day T, A, find the accumulated sales for the first 7 days. B, find the sales from the second day through the 5th day. This is the interval from 1 to 5. So we have this hint for part B. For part A, accumulated sales the first 7 days, so 0 to 7. $30 e to the power t dt. We can take the 30 out, 0 to 7 e to the power t dt. The antiderivative is the same function, 7, 0. We're going to have parentheses minus parentheses. The first parentheses, we have e to the power 7. The second parentheses, we have e to the power 0. And that gives e to the power 7 minus 1. Okay? Nearest cent as needed. We are increasing in dollars per day. So let's see how much sales company estimates that the sales will grow continuously. Okay. In dollars per day. T is day. T is in day. S is in dollars. Okay, looks good. We need to find the value for 30 times e to the power 7 minus 1. 30 e to the power 7 minus 1. How do we run it? Nearest cent. 99 cents. Double check the entry. Okay, part B. It says from 1 to 5, right? So just change the interval. Everything else is the same, just change that to 1 to 5. This is 1, this is 5. This is the interval from 1 to 5. Okay. And everything is the same. So this is from 1 to 5. And this is 1, this is 5. 1 to 5. So here we're going to have when we plug in 5, e to the power 5. When we plug in 1, e to the power 1. So just the e. So we have 30 times parentheses, e to the power 5th minus e. Oh, did I make a mistake? 5. Just 5 minus 30 e 5th power minus e. Nearest the cent, so 85 cents. $4,370, 4,370.80. All right, next. Question number 9. Evaluate from 1 to e to the power of 6. And integrate the function into x plus 4 over x dx. So the n-time for x is x squared over 2. And that one is 4 ln n absolute value of x. But since the integrals from 1 to e to the power of 6 are positive, we do not have to worry about the absolute value. We can just write ln x. Okay? Double check. The derivative of x squared over 2 is x. The derivative of 4 over x is 4 ln x. Sorry, the derivative of 4 ln x is 4 over x. Okay, so here's e to the power 6, here's 1 parentheses minus parentheses. In the first parentheses, we plug in e to the power 6. To power 2 over 2 is 4 times ln n e to the power 6. And plug in 1, we have 1 squared over 2 plus 4 ln 1. Simplify e to the power 6 and then to the power 2, that gives e to the power 12. Plus 4 times 6 is 24. And then e. And then e is 1. Okay? So we can move the 6 in front. And we have 4 times 6 is 24. And then e is 1, so it's 24 here. And minus half. And minus. And then 1 is 0. So we don't have this term anymore. So just the minus half. Type an exact answer. So we can have e to the power 12 or 2. That is 48, 47 over 2. 24 is 48 over 2. 48 over 2 minus 1 over 2. So 48 minus 1, 47, 47 over 2. E to the power 12 plus 47 all over 2. I need to double check the result. 1 e to the power of 6. The antiderivative is x squared over x plus 4 ln x. When we plug in e to the power of 6, we have e to the power of 12 over 2. And plugging e to the power of 6 here, we have 24. And then minus, plugging 1, half. Plugging 1 here is 0. 24 minus half is 23 and a half, which is 47 over 2. So e to the power of 12 plus 47 all over 2. I think that should be correct. Sorry, I need to do this. Plus 47 over 2. Next. Question number 10. Absolute value. So this is a good problem. It's important to know absolute value of x equals x as x is bigger than or equal to 0. Absolute value of x equals negative x as x is less than 0. So here we have the absolute value of x minus 2. So that means when x is less than 2, x minus 2 is negative, right? So the integrated function is 2 minus x, okay? When x is bigger than 2. When x is bigger than 2, x minus 2 is a positive. So when the quantity is positive, we can just remove the absolute value is x minus 2. So this is very important because 2 is between 0 and 3. So we have 0 to 3, x minus 2 dx, that's the given integral. We're going to use the property of the definite integral to write this integral as from 0 to 2 plus 2 to 3. From 0 to 2, that means x is less than 2. When x is less than 2, the integrated function is 2 minus x. From 2 to 3, that means x is bigger than 2. So the integrated function is x minus 2. Okay. The anti is 2x minus x squared over x over 2. 0 to 2. This one is the same. Is x squared over 2 minus 2x. 2 to 3. So we're going to have this. Plugging 2 here, we have 4 minus 2 squared is 4. 4 over 2 is 2. Okay, plugging 2 here, we have 4 minus 2. Plugging 0, we have 0. Plugging 3 here, we have too small space. Plugging 3, we have 9. 3 squared is 9. 9 over 2 minus 6. And plug in 2, we have 2 minus 4. Okay, so we have 4 minus 2 is 2, plus 9 over 2 minus 6, plus 2. 2 minus 4 is -2. Negative 92 is positive 2. Nine over 2 minus 2. That's what I get. Okay, actually we can double check by using the geometric significance of this problem. Function y equals absolute value of x minus 2 is this, look like this. So from 0 to 3, 0, 1, 2, 3. So what's the area of this region? And this triangle has area base times height is 4, 2. And this area base is 1 times height is half divided by 2, so it's a quarter. Added together the 2 and a quarter, so is 9 over 2 is called, oops. 0 to 3. The top is 1. This height is 1, not half. 1 times 1 is half. So 2 and a half, so it's 5 over 2. Yeah, that's correct. Definitely is correct. 5 over 2. Type an integer or a simplified fraction. So if you type in 2.5, even if the same with the 5 halves, it will be marked as wrong. So read the instruction carefully. 5 over 2. Question number 11. Find the area of the region bounded by the graphs of the given equations. We have cubing function y equals x cubed and a straight line y equals x. Let's graph the diagram. X cubed look like that. Y equals x look like that. From 0 to 1. So basically it's this tiny area. Okay. And knowing in this tiny area, if you zoom in, the straight line y equals x is above y equals x cubed. Okay. From 0 to 1, x is bigger than x cubed. When x is between 0 and 1, x is bigger than x cubed. So the region, the area of the region is from 0 to 1, x minus x cubed. X. 0 to 1, x minus x cubed. So the parentheses minus parentheses. If we plug in 1, we have 1 squared over 2 minus 1 to the power 4 over 4. Plugging 0, we have 0. So it's a half minus quarter. It is a quarter. So quarter. How do we double check if this is correct? We would have to check the process we did earlier. From 0 to 1, x minus x cubed. 1 half minus quarter. Yeah, so quarter. Question number 12. The company determines that its weekly online sales ST in hundreds of dollars T weeks after online sales began can be estimated by the equation below. Find the average weekly sales for the first 6 weeks after the online sales began. First 6 weeks. So from 0 to 6. From 0 to 6, average weekly sale. Okay. From 0 to 6. So the formula we're using here is a to b f of x dx over b minus a. That's the definition of average. Without change. No, not without change, I'm sorry. Is the average weekly sales in this case. Weekly online sales ST. Yeah, so we're accumulating the sales from the first 6 weeks and then divide by the number of weeks. That's the idea. So we're gonna have from 0 to 6 ST dt over 6 minus 0. From the first 6 weeks, the number of weeks is 6. 0 to 6, ST is 6, e to the power of t dt. We can move this 6 outside and then cancel with this 6. So we have 0 to 6, et dt, and et 6, 0. E to the power of 0, 6 minus e to the power of 0. So e to the power of 6 minus 1. Round the nearest cent as needed. E to the power of 6 minus 1. E to the power of 6. Okay? Dollars. And this question, we need to be very careful. We have to multiply 100 here. You should see similar homework assignments. And you know you should do this. Multiply 100. Nearest cent. So it is question number 13. 19 x plus c 11. So this is x to the power of 12 over 12 plus c. This one is going to be 3 e to the power of 7x over 7 and then plus c. You remember you should double check, right? So if we take the derivative of e to the power of 7x, we have e to the power of 7x times 7. Now 7 will cancel the 7 in the denominator, and we have 3 here. So that's correct. 14 to the power of x. It should be 14 to the power of x over ln 14 plus c. So what's the derivative of 14 to the power of x? It is 14 to the power of x times ln 14. And now we'll cancel ln 14 on the bottom, gives the original integrated function. Right? Check the formula. And this one, we can use the geometry to solve the problem. The integrated function is 8, y equals 8, so it's a horizontal 2, 3, 4, 5, 6, 7, 8. It's a horizontal straight line. From 0 to 3. From 0 to 3. So the integral actually equal to the area of this rectangle. The base is 3, the height is 8. 24. Another method, 0 to 3, a dx. The anti is ax. Plug in 3, 24, plug in 0 is 0, so 24 as well. Definitely is 24. Question number 18. And we can also use the similar problem, a similar method with geometric significance. So the function is y equals x, is the bisector of quadrant 1 and quadrant 3, right? And from 0 to 5, this is a 5. The 0 is for 5. So we are basically looking for the area of this triangle. Base is 5, height is 5. Multiply together divided by 2, so the answer is 25 over 2. If you use the integral method, the anti is x squared over 2. Plug in 0 is 0. Plug in 5 is 25 over 2. It's the same thing. 25 over 2. Question number 19. You can use a similar problem, a similar method, or you can just use integral. The anti is 1 over 4x squared. Yeah. If you take the derivative of this function, you would have 1 over 4, 2x, that is x over 2, okay? Half of x. So that's the anti. Upper limit, lower limit. Plug in 8, plug in 0, plug in 0, cancel. Plug in 8 is 1 over 4 times a squared, 64, 16. If we draw the graph, y equals half x, so the slope is half. That means if this is 2 units, this is 1 unit. And from 0 to 8. So if this is 8, this is going to be 4. base times height divided by 2, 16 as well. Question number 20. Anti is 3x, x squared over 2. This is 5, this is 3. This minus this, plug in 5, 3 times 5 is 15. Plug in 5, 5 squared is 25, 25 over 2. And then plug in 3. 3 times 3 is 9. 3 squared is 9 over 2, right? Okay. And 15 plus 25 over 2 minus 9 over 2. Be careful with the sign. 15 minus 9 is 6. And that gives 25 minus 9 is 16. 16 over 2 is 8, so this gives 14. If we use the graph, y equals x plus 3 is a straight line. 1, 2, 3, 1, 2, 3. It's like this. Okay? And from 3 to 5. 2, 3, 4, 5. It's a trapezoid, kind of, or a rectangle with a triangle. It's supposed to be 45 degrees here, okay? If we use the triangle, if we use the rectangle plus the triangle, is 2, 3, 6, 4 plus the area of this triangle, 2, 2, divided by 2 is 2. 14 as well. It's 14. Next. Question number 21. Find the area of the blue region. Okay. So base is 2. Height is 3. Base times height is 6 divided by 2 is 3. That one is very straightforward. Let me double check. Find the area under the given curve over the indicated interval. The curve is a horizontal straight line from 2 to 4. So the area is going to be a rectangle with base 2, height 3. 2 times 3 is 6. Why did I enter 3 here? 6, okay? Yeah, base is 2, height is 1, 2, 3. 3 times 2 is 6. That's the area. Question number 22. Find the area under the graph over the interval. Okay, so then it's 3 to 3, e to the power x dx. The anti is e to the power x. Plug in 3, plug in negative 3. So we have e cubed minus 1 over e cubed. Type an exact answer in terms of e. Yeah, we're gonna enter that e cubed minus the reciprocal of e cubed. E cubed minus e to the power negative 3, which is 1 over cubed. Right. Question number 23. Evaluate. e to the power of x, e to the power of t is the so -5 to 2. So plug in 2, plug in -5. The same type of problem as earlier. So we have e to the power of 2 minus 1 over e to the power of 5. Double check. Question number 24. Find the area of the region bounded by the graphs below. So we have two graphs here. One is y equals 5x minus x squared is a parabola facing downwards. The other is a straight line. You can use the graphing calculator to help you to find the intersections of the two graphs, or you can equate the equations, the two equations. Make 5x minus x squared equals x. Solve for x. Then we have 4x minus x squared equals 0. Factor x out, and 4 minus x equals 0. So x equals 0, or x equals 4. Okay? So if you use your graphing calculator, you probably would see the two graphs intersect at x equals 0 and x equals 4. Okay? That. So the area of the region would be from 0 to 4. The parabola minus the straight line, so it is 5x minus x squared. That's the parabola minus x, the straight line, dx. We should have found the derivative. We should have found this integral. Parabola minus the straight line. Let's simplify the function 5x minus x is 4x. Anti is this. Equals this. So plug in 0 is 0, plug in 4 is 2 times 4 squared minus 4 cubed over 3. 4 squared is 16. Double 16 is 32 minus 4 squared 16. 16 times 4 is 64 over 3. 32 times 3 is 96. 32 over 3. Is that correct? 32 over 3. Let me double check. 4x minus x squared. 2x squared minus x cubed over 3. Plug in 4. 32 minus 64 over 3. 96 over 3 minus 64 over 3. 32 over 3. Okay. Next. Find the area bounded by this is a like S shape curve, polynomial with degree 3 and x-axis, and the first coordinates of the relative maximum and the minimum values of the function. Okay. Yeah, this question brought in the extrema, relative extrema from the previous unit. Now, how about let's find the relative extrema? The function y equals x cubed minus 12x plus 16. So look like this, okay? Like that. So x cubed minus 12x plus 16. And the derivative is 3x squared minus 12. Okay? And make it be 0. We're looking for the critical value. We have 3x squared over equals 12 divided by 3. We have x squared equals 4, x equals -2, and x equals +2. Okay? I'm going to use the second derivative test. Double prime is 6x. So when x equals 92, double prime is less than 0. So it's concave down, so there's a maximum. When x equals a +2, double prime is positive, so concave up, minimum. Okay, so the two extrema, we do have two extremas, relative extremas, 92 and 2. The first coordinates of the relative maximum and the minimum. Then the area bounded by this x-axis. So we're going to have from 92 to +2. The function is x cubed minus 12x plus 16. X cubed minus 12x plus 16 dx. I'm going to use a shortcut, okay? I'm going to split this integral as 92 to 2 x cubed minus 12x dx and plus 92 to 2, 16 dx. And look at this one. The integral function x cubed minus 12x is odd function. If the function is odd and the lower limit and the upper limit are opposite of each other, the derivative is the integral is 0. It's 0, okay? So now we have 92 +2 16x. That gives 16x 2 to 92. So basically we are looking for the area of the rectangle, right? Just imagine is y equals 16, and from 92 to +2. The base is a 4, height is 16. Base is a 4, height is 16, so 64. The area is 64. Let me double check. X cubed minus 12x plus 16 minus 12x plus 16. Yeah, 64. Let's see, number 5. Mess up half question. This about, okay. So you answer, okay, the first one is, the second is correct. The first one is wrong. We can do it again. Okay, let's go back my note. 2, 4, 6, 8. 4 rectangles. The base is 2. 2, 2, 2, 2, no problem. The height is f of 2, f of 4, f of 6, f of 8, no problem. And bring 3 out, we have 6. And so 1 over 2 squared, 1 over 4 squared, 1 over 6 squared, 1 over 8 squared. What's wrong with that? 36, 16, 4. And let's do the calculator again, okay? Maybe we messed up the calculator, or I forgot to multiply the 6. So 1 over 4 plus 1 over 16 plus 1 over 36 1 over 64. Am I right? 2 squared, 4 squared, 6 squared, 8 squared, and times 6. What's the answer? Answer is 2.1355. 2.1355. 1354. It's a little bit different. Okay. I think I might forgot to divide by, I think I messed up the calculator part. The expression, the process is correct. I think I just messed up the calculation. All right, guys, that's exam 4. I'll see you on the other reviews.